Hi, and welcome everybody to this webinar on CluedIn and Azure OpenAI. Today, we're going to have a look at not just what generative AI can do in general, but specifically also how CluedIn is using generative AI to make master data management work in ways that have never been possible before. My name is Henri. I work as a cloud solution architect for Azure Data and AI at Microsoft Denmark, and I have the pleasure of working with CluedIn, not just on kind of working on their machine learning and AI setup, but also specifically around generative AI. And that's, of course, a super exciting area for a lot of us right now. Today, we're going to be talking about first, what generative AI even is. How is it different from AI traditionally in the kind of the old traditional ways of doing AI? But then luckily, we're going to have Tim from CluedIn actually join us to show in practice how AI can be used to, for example, do really smart things in master data management. I'm going to come back later to round it off and talk about some very important topics as well when we talk about AI, specifically things like privacy, data security, and responsible AI. Now, I want to kick it off with why we're even all here. Obviously, we're all here because AI is really on everybody's mind right now, right? There is a lot of media coverage, a lot of buzz on LinkedIn. I'm pretty sure everybody is talking about AI. Lots of companies right now are also trying to put AI into their products. Some companies, hint, hint, are faster than others at that. But I want to start with actually just some terminology. When we talk AI, we also often mention other words like machine learning. And then when it comes to generative AI, how does that relate to all of that? It makes sense for us to just take a moment and kind of define the terms to make sure that when we talk about AI, we actually talk about the same things. You might be surprised to hear that the concept of AI is actually quite old. Even 1950s, that's when the concept of artificial intelligence started to arise. Now, I found that surprising when I learned that, because usually when we talk about artificial intelligence, we think about something futuristic and new, right? Not something from the post-war era. But artificial intelligence back then was very different, of course, than it is today. And that's mostly because when we talk about artificial intelligence today, we talk about machine learning. Right? That's the way we've been doing most artificial intelligence, since around the 90s. This is when artificial intelligence really started being useful. And a lot of the AI applications that you see today, they are actually based on machine learning. Most of these applications, things like, for example, your Google Translate or your Amazon Alexa, these are all examples of deep learning. Deep learning, essentially, just a bigger version of machine learning. This is where you get your neural networks, types of machine learning that are kind of emulating the way our brain is working. Deep learning has made it possible to do lots of tasks that emulated human cognition, things like working with language and speech and making decisions, sometimes even rivaling or surpassing the ability of humans to do the same. A particular part of deep learning is then generative AI. And this is specifically what we're talking about today. Generative AI has really only been around for 2 years or so. It's a relatively new field. Sure, we've been able to, do things like generating text before, but only recently have we started to be able to generate, not just text, but also images, and doing all of that based on natural language prompts. This is a very important detail that, later in Tim's demo, you will actually see how, much opportunities you get out of being able to generate things based on natural language inputs. So actually, let me just go back one slide here. When we talk about machine learning, when we talk about AI, when we talk about generative AI, we always talk about, one part of this greater hierarchy. All of this is artificial intelligence. Most of it is machine learning. Nearly all of it is deep learning. And then what we're talking about today, that is generative AI. Most of the generative AI that we are talking about today, or actually all of it that we're talking about today, has come out of a collaboration between OpenAI and Microsoft. You've likely heard about those two companies. OpenAI and Microsoft started, well, I'm assuming you've heard of Microsoft, but I'm pretty sure you've heard of OpenAI as well by now. These two companies started collaborating in 2019 when OpenAI needed extra compute power to power the development of their language model, GPT-3. That's when they started working with Microsoft, because Microsoft, has all of those large data centers with plenty of compute power. And as a result of that collaboration, we've seen all of these generative AI models come up. Models like GPT-3 and 4 for text, ChatGPT for conversation, Codex for code, and DALL-E for images. Now, we're not going to be talking so much about images today. Specifically, we're talking about master data management. So images might not be the most relevant here today, but just to give you a few examples of what you can actually do with generative AI. We can do text, yes. We can do conversations, essentially text back and forth. We can do code, both traditional, let's say, code like application code, Java, Python, but we can also do other things that might not usually be considered code, SQL, HTML, JSON, all of these kind of more like structured examples of language. And of course, we can do images too. Now, one very interesting aspect of working with generative AI is the abilities we have to actually customize that. And the kind of discipline of customizing language models specifically, or image models as well, generative AI models in general, that's referred to as prompt engineering. So we can take these base models here that we have, and we can actually just customize them with our own data and our own prompts. So of course, if you've used, for example, just the private, the free ChatGPT preview, then you know that of course you can ask your own prompt, you can ask your own question. But where it gets really powerful is when you can also add your own data. And this is what separates just typing a question into ChatGPT from actually having an application, an AI-enabled application that creates some true value. Here's an example of that. Let's say we have a prompt. Maybe we want to have one of our language models generate a tagline for an ice cream shop. Sure, that's great. Maybe it's something like scoops of heaven. That's a good tagline. But where this becomes really relevant for our business is when we can get that tagline specifically for our ice cream shop, not just any ice cream shop. The way we do that is by providing meta context. And this could come in many forms. This could be information about, for example, where our stores are located. This could be information about what the values of our ice cream chain are. Maybe this is information on what we want the user to think about or to associate with our company when they hear our slogan. That way we can actually have it generate a slogan that's really, really, perfectly bang on for our business. Now, there's a lot of things we can do with generative AI. There's really a lot of capabilities. But today we want to go down on one particular example. And that is how we can actually use this for master data management. I'm going to hand it over to Tim now, who's going to show you what Microsoft and OpenAI, including on collaboration, have been able to do when it comes to using generative AI to enable master data management in a way that just hasn't been able or hasn't been possible before. Over to you, Tim.
Thank you so much, Henri. So I'll echo Henri's point about the excitement that I think the whole industry is feeling. And one of the things that Henri and I wanted to make sure we brought to this conversation was, first of all, some really practical and tangible ways that this can be applied in production today. The other thing is we wanted to give you some pretty jaw-dropping examples that could get your head spinning around how you could use it in the data management cases. Now, before we dive into the demonstrations, let's provide a little bit of context. We're all here for a couple of reasons. One, we want to see the practical use cases. And the other, we want to see how I guess, some of the challenges and the opportunities that we have focused in on the governance and master data management pieces. As Henri alluded to, there's so many different applications for this. Let's not boil the ocean. Let's get some real value today, and let's all start by, I guess, going back to why we're all on this call together. I think everyone on this webinar would probably agree that there's been some pretty fundamental shifts in our industry over the last 10, 15, 20 years. And without any real big surprise, of course, cloud was one of them. Moving from off-premise, on-premise, onto the cloud, enabling those easy access to services, in a way, unlimited access to hardware, compute, processing, etc., has fast-tracked out the things that we can do with our digital transformation. Of course, moving more away from waterfall-style approaches to big bang projects, moving to more quick agility, and then finally focusing on automation, which is where obviously some of the AI pieces come as well. And the reason why we're following these market trends is because many of us are maybe just starting our digital transformation, but for the majority of companies, we're dead bang in the middle of that transformation. But one thing is known, that transformation will never stop. There'll always be a way to move the needle. And in some cases, like the introduction of these new large language models, it's not moving the needle, it's making quantum leaps to be able to build better products, understand our customers more, to be able to have happier employee engagement, to understand our markets, and to be proactive as well about it. And another one reason why we're probably also on this call is because if we look at the technology stacks that we're all putting together today, we've all been pretty good citizens. We've bought the best in breed cloud, we've invested in BI and machine learning AI, we've bought lakes and lake houses and warehouses, and we've invested in the best talents in the industry. But yet, with all of this combined, it still feels like there's these voids and chasms from us being these kind of properly data-driven, data-fueled businesses. There seems to always be this kind of cog spanner in the work. And I know what you're probably thinking. It's, okay, is the answer to this Azure OpenAI? And the answer is, well, no, not really. And you're probably also thinking, oh, okay, well, Tim's going to say the answer is MDM. That's also not true. The thing that's missing is fundamentally, where is the business playing a role in the supply chain of data? If we look at the stack that we're just talking through, AI, ML, BI, lakes, warehouses, lake houses, these are all inherently very heavy techie systems implemented by IT and operated by IT as well. And so really, if we go back 30 years, this concept arose 30 years ago that said there needs to be some introduction of an operational system for the business users to play a role in these inherently tech stacks. This concept was coined master data management. And if you fast forward 30 years to today, that involving the business in this operational chain is not something that the majority of companies have in place. This 30 years has allowed us to accrue enough scar tissue to have some of the analysts generate statistics like this. High failure rates of implementing things like master data management and bringing the business into this supply chain. And it's not really without any surprise why this is. When we have parts of the supply chain that kind of breach outside of IT, these are things that we can't hide behind IT and engineering teams. We are, in a way, letting the ugly baby out to the world of all of our technical debt, the complexity of bringing our data together. These are some of the reasons that have led to these pretty bad rates. This was roughly in early 2022, late 2021, that this kind of statistics were coming out. Yet why was this the case? Why was MDM always so hard to implement? Well, if we take a look at the kind of anatomy of a typical MDM project, and we look down the bottom at the kind of time frames on the x-axis around how long these projects actually took to kind of get in production and proving value. It's of no surprise that some of the real complexities that made MDM traditionally hard was that before we even started to use these systems, we needed to model our world up front. We needed to figure out not only what our world we want it to look like, but what we want it to look like in 5 years' time. And this required a lot of upfront analysis, a lot of upfront complexity around figuring out how all your data fits together. And the irony being that for the first 6 months of these projects, your MDM system was turned off. And the other piece, getting back to the core inception of MDM, it was about bridging IT and business. Yet the majority of these traditional approaches to MDM typically resulted in these things being handed back to IT to not only implement, but to operate as well. And in this new world of large language models that can understand unstructured data, we were kind of always working towards the limitations of these technologies, in that master data management is all about heavily structured data on a short list of very common domains, things like customers, vendors, suppliers, materials. Yet if we actually look at one of the main reasons why we're wanting to look into technologies like MDM, it's because we're wanting to give the business users the ability to play a role in the supply chain. And what's important around building a single view of our data across our estate very much spans across just outside of structured data. If I'm wanting a single view of our customers here at CluedIn, that's not only the contact details and the contacts associated with that company, but it's also the emails that I'm sending them. It's the invoices they've been sent. It's the PowerPoint presentations that our teams have shown them. And all of this resulted in this very waterfall style approach, this slow time to market, where until we actually got that beautiful canonical model in place, we couldn't actually start to leverage the other parts that MDM was supposed to help us solve. 24 months down the track, it was no surprise that these things weren't in production and other teams moved on. They had to get the value they had to prove in their teams from somewhere else. This is why CluedIn exists. CluedIn is a Microsoft native Azure solution based on a couple of core pillars of modernization, including graph, automation, cloud, and now in the integration with Azure and OpenAI as well. All this leads to is a platform focused on agility, on automation and augmentation, and flexibility to be able to adapt to the natural entropy and change that happens within a business. Even without the new Azure OpenAI stuff, it's important to highlight a couple of the big pieces that CluedIn has brought to the market. Number one, CluedIn is installed inside your own Microsoft environment, just like some of the other native Azure services, whether that's Microsoft Purview, whether that's Synapse, whether that's Databricks, you name it. Installed inside your environment with the data sovereignty inside your tenant as well, which was another reason why it was important for CluedIn to integrate with Azure OpenAI, not directly with OpenAI itself. The cleaning, the stewarding, the ability to fix the data that sits within your business to fuel these insights from the innovations we wanted from that previous era that Henri talked about in deep learning and machine learning. We all realized that era shone a light on the fact that most companies did not have the right foundation of data in place to be able to yield the value out of that. Quite ironic of what an iterative and flywheel approach this is, that now for us to solidify the last parts of our data foundation, we can start to lean on AI to help us with that. With Azure OpenAI now in the circle and integrated into the platform, there's a couple of key demonstrations I'm going to take you through today that span across these main categories. Henri talked about this quantum leap in the natural language way we have to interface with these new machine learning models. This, by far, in our experience with our lighthouse customers of CluedIn and Azure OpenAI, has been the biggest eye-opener. It's also been the biggest bridge between the business users being able to have the power of not only what could only be done in IT and engineering, but in the examples that we're going to talk you through, these are even examples of things that IT and engineering teams would find extremely hard to build, to maintain, to deploy, and run in a production state. All of this in a risk-free automation. One of the biggest complexities that we've seen is the adoption of AI, in that without the predictability, without the ability to bring humans into the loop, without the ability to explain exactly the reasoning behind the answers that are coming from the prompts that we are giving to the large language models, that's necessary to be able to close the loop of being able to use AI in production and operational environments. And all of this results in accelerated time to value. In addition to this, some of the more complexities around implementing data governance programs, where we have these very top-down ambitions and aspirations to put in data policies and standards around our data. It's a great idea. It's a great ambition. Easier said than done to actually implement out there in the data. OpenAI has now given us all superpowers to be able to bridge this gap that made those types of things complex to do. Now, what does CluedIn bring to this integration? You know, you've got the large language models. Are they doing all the grunt? Well, if you've had time, which I'm sure a lot of people on this call have, to spend time with the large language models, you'll realize that the nuance and the trick is really in your ability to write the kind of prompts that provide as much context as necessary to pinpoint a precise response from the large language models. You'll probably also join me in agreeing that the large language models will get things wrong all of the time. That's a truism that we should all go into in embracing this in the different use cases that we're applying it to. What CluedIn brings to the integration is this. If you are to go into, just a silly example, if you are to go directly into the prompt and you're to write, who is the CEO of CluedIn? The answer will embarrassingly come back with something like Morten Nielsen. Now, Morten Nielsen probably doesn't even exist as a real person associated with CluedIn in any shape or form. Taking that same question and putting it into the CluedIn integration to be able to ask that question somehow yields the correct answer. Why is this? Well, whenever we are prompting from the CluedIn integration to OpenAI, behind the scenes, we are using the native graph that we use to model the relationships between the employees and the companies and all of these different domains you have in your CluedIn MDM system. We're using that to append automatically extra context to be able to define a more precise and focused response from these models. It's the context we provide to these prompts which make these prompts less creative, more rigid and specific in its structure and its responses. And this is absolutely key to be able to operationalize this in production systems. OpenAI is now at the heart of the engine of the CluedIn platform. And this is just adding to the ever-growing list of native integrations that CluedIn has to the Azure stack. Everything from Microsoft Purview to the Power Platform for workflows to be able to bring humans into the loop when the confidence level of these responses from OpenAI may be lower. We want to bring a human into the loop to be able to cut off and short circuit that automation that is not what we're looking for from things like OpenAI. We are looking for co-pilots, augmentation that accelerate and help us in being able to clean, master, and apply the governance rules over our data. So let's see it in action. I'm going to take you through 3 different examples. The first is how we can take natural language data policies, have them actually enforce the change that we're wanting to put specified in our policy. We're going to use a simple example where we want all of our employees that have their phone number data in all different standards. Sometimes there's hyphens in it, sometimes it's missing dial codes, sometimes there is spaces between the numbers. It's in just dirty, denormalized formats. Using these policies, we not only want to write what we want the data to look like, we will have it actually run against the data as well. We're also going to use this for data enrichment. We've got an example where we have data we do not have in the platform. We're going to show how easy it is to enrich your existing data for records and values that you do not have any internal information on. And finally, we're going to touch on some complexities around privacy and compliance. Of course, if you're using tools like Microsoft Purview, you'll know that it's proactively scanning for and classifying your data when there's known patterns in the data. That's why it's very good at picking up on things like credit card numbers and social security numbers. But what about the data that is not does not contain patterns in it? Job titles. There's no pattern for detecting that. What about the mention in unstructured data of individual salaries? How do you detect these types of things so you can lower the risk you have in privacy PII data leaking out into other use cases within the business? So let's head over and take a look at a bit of tech. In this particular scenario, I'm going to start with, I've got Microsoft Purview set up. And this is where all my data across my entire CluedIn landscape exists. Our files, our tables, our reports, and everything. And today we're going to be dealing with some HR data, some pretty sensitive data. You can see that Purview has automatically applied some classifications to tell me that there's certain files that have credit card numbers in it, IP addresses, and things that could be considered PII. If we head over to CluedIn, due to the fact that we've got a native integration into Microsoft Purview, it allows me to then view our data sources, and I can actually explore all the assets in Purview, search through it directly from CluedIn. In this particular case, we're going to head down to the HR folder, where we're going to change the discussion now. Instead of talking about files and tables, we're going to start to talk about records themselves. Here we see a nice preview of the data that we're dealing with that has come in from our Purview account. And there's some pretty sensitive data here. We've got things like addresses, emails, passports, we've got bank account numbers. And what we've done in the platform is we've mapped the data in CluedIn. So instead of talking about CSV files and where it came from, we're going to change the discussion that now we're going to be talking about employees instead. So one of the most important things that MDM brings to the market is that we're going to take the discussion from a non-technical discussion to a business discussion. So we're no longer going to be thinking about CSV files. We're now dealing with a group of employees that we have within the MDM system. And so if I head over to my search, you can see that I've got my employees imported into the system. And it's great because we can see we've got job titles on absolutely every one of our employees. And we're using this already to fuel a Power BI chart. This is something that our management layer uses to be able to see the distribution of job titles we have across our business. Now, to be completely honest, when I look at this pie chart, it's pretty useless to me. As a management level, it would be really hard for me to make decisions considering the scattered and dispersed nature of this. I need to understand what departments do these individuals work in. Now, when we're talking about 100 employees, you could probably manually go off and do this. Of course, you're going to have to redo it every time that new employees come on. But if you're a business that has 10, 50, 100,000 employees, this is something we want to automate. But you can probably imagine, well, you all are aware, how imaginative people can be with their job titles this day. So applying a kind of traditional IT engineering-based approach to this would be time-consuming, expensive, and something we'd have to constantly maintain. Let's go and solve this specific issue right now. For this, I'm going to head over to my management section and head to the rule builder. Here, I've created a couple of different business rules in CluedIn. They're all inactivated right now. So let's go and have a peek at how you set up the integration between OpenAI and CluedIn, and let's activate it and run this. So here I have a simple business rule that's saying add the department based off the job title. Here I put a filter to only apply this to the records that are employees. We might have organizations in here, we might have departments, we might have contacts, deals, leads, you name it. We only want to apply this particular data transformation to the employees. Down here, I have two different actions. The first, as we open this up, uses our integration to OpenAI and simply asks a prompt. Given the job title of insert job title, what department in a workplace do these people usually work in, and just return the name of the department. This token-based system here is used to take the context record we're wanting to process this again and insert the value of the job title. That gives us the prompt that we're going to then hand off to OpenAI to do the work. The next thing I'm going to ask is, on top of that, I'd like you to ask the same question, but the response I'd like is different. Once you've chosen the department, I'd like you to explain in detail why you chose that department. And this is one of the ways that we can help unravel that black box of AI. We suddenly have the ability to have the explanations behind the reasoning that we get back from these large language models. Okay, so with that in play, let's activate this guy. Let's head back to our results and let's take someone like Egan. If we take a look at Egan's single view, everything we know about Egan is in one place. Here's the metadata that we have on Egan. Things like his bank account. We can see that he works as an account executive, but there's no mention of a department of what Egan works in. Now that we've activated that rule, let's go off and run the rules against this particular record. Naturally, this will go off to ask OpenAI the prompt that we set up. And as we refresh the page, you can see that two things have been done. First of all, we now have the department. Second of all, we now have a detailed explanation giving us as stewards the reason behind sales being chosen as the department. Now, if we head back to our Power BI chart, okay, now my Power BI chart is set up as a live stream of output, and I can see that my sales department is now showing up there. Let's go back and let's run this in bulk. So let's just say we'll run this against 20 of our employees. Run that. Head back to our Power BI chart that's set up as a live stream of data. So now it's going to take those 20 records. It's going to ask the prompts off to that OpenAI model. Once it has the response and the explanation, we are going to see in front of our eyes these departments being automatically filled in. Now, from a management perspective, this is much easier for me to make a decision on. I can now see the distributions at a more abstract level with the department. This is data that did not exist before. We have used large language models to enrich this. This is now set up as an automation. As new employees are onboarded, these departments will be allocated. Okay, so that's some enrichment. Let's go look at some data standardization. Let's head back to our rule builder and let's take something like standardizing of phone numbers. Once again, we've applied a filter to only do this for employees. And if we take a look at the action that we've created, if we zoom in here, this is probably a fair policy that I would register in my data governance system, where we want all of the phone numbers on our employees to be in an RFC 3966 standard or an E164 standard. These are standards for phone numbers. Now, although this could be a sentence that I would register in my governance system, well, I've still then got to go out and actually apply it to the data where it's being used throughout the business. You can probably gather you don't need to do this anymore. We are going to activate this rule as well. We're going to head over back to our search. We're going to take someone like Queenie, head to her properties. Here's her phone number. Let's go and activate and reprocess that record. And once the OpenAI has done its job, you might need to give it a few seconds. You can see now that my phone number has been automatically transformed into the RFCC 3966 standard. So you can see how these policies now can become the enforcer of the actual transformation in a reliable and in a automated approach as well. The next example we're going to walk through is detecting private data that's not so easy to detect with patterns. So here we're going to have a rule that's detect PII that doesn't follow patterns. Okay, great. Now, instead of running this in bulk, I thought I would show this example in a different form, i.e., once we've built the rules and the prompts in CluedIn, let's go and take this from another angle. So here, I'm actually just going to ask the same thing I would have set up in CluedIn. I'm just going to ask it directly in the prompt. Does the following sentence have PII data in it? You can see pretty obviously that this is referring to the salary of an individual. Okay. Once we ask the AI to return our model, you can see that it's confidently saying, yes, this sentence contains PII data. If I wanted to have this talk back to me, like Henri said, in a predictable, machine readable way, this is where I might change the prompt to say, return the result as either true or false. And you can probably imagine this is something that makes it much easier to systematize and automate the integration between the natural interface, bringing it back into an actual automated, codified way. So let's give another example here. So I'm going to paste this result in here where it's still mentioning things around dollar signs. It's still mentioning the word salary, right? So traditional approaches, you might say, I want to check for things like the word salary. I want to check for things like dollar amounts. This doesn't always result in the data actually being PII. So you can see in this example, it's actually clearly returning, no, this does not contain PII, even though it has the same elements, the same keywords, the same tokens. These are some of the traditional approaches that you would take. Unfortunately, these traditional approaches are expensive, they are complex, they require IT, they require data science, they require maintenance, redeployments, labeling systems to make it better over time, and all of that results in extra cost. Integration with the large language models are a nice general way to get access to general models. Obviously, you can probably imagine we'll see an influx of specific models that understand the legal space, the financial services space, the pharmaceutical space. In its current form, it's very good at general topics, even things like detecting PII sensitive, PCI DSS compliance, HIPAA style of PII data. What's the value of this? We're bridging that immense gap that exists in where is the PII data in unstructured data. I think the majority of us are pretty content with the ability to detect data that has patterns, credit card numbers, IBAN numbers, social security numbers, passports. But what about credit card numbers that have the last number missing? For me, there's only 10 possible guesses I have for that last number. That for me still alludes to something that could be considered as PII data. What about detecting a job title in unstructured data? Yet again, another thing that obviously does have patterns in it that allow the large language models to detect it, but something that requires a huge corpus to be trained on, something that is ubiquitously packaged up in a bow, available to us with the use of the Azure OpenAI integration. Some of the other examples that I've got here, just to provide a little bit of inspiration, I guess, to detect, for example, things like tagging of anomalies in data. For example, if we've got the genders on all of our employees, and suddenly one of those genders is actually a phone number, to be able to automatically tag that with data quality issues. The fact that we can generalize this now to not have to codify, I should be looking for emails or phone numbers and detecting that, but rather in a general, natural language to be able to say, just tag if there are anomalies in the value. You can imagine how much this accelerates, but also simplifies the process of being able to introduce these types of prompts. So before we head back into the slides, we've had this running with a couple of our lighthouse customers. The official launch of this integration with Azure OpenAI is live today. There is a 7-day trial of CluedIn that has been deployed today. It gives you access to not only 7 days of using the other parts of CluedIn, like the Purview integration, the data stewarding tool, the hierarchy management, building of workflows with Power Automate, integrating with the common data model, integrating with Power Apps to be able to build applications on top of your master data, but the Azure OpenAI pieces as well. So let's head back in and let's close things up before I hand back to Henri. CluedIn was fortunate enough to be one of the inception partners of the Microsoft Intelligent Data Platform. This was something that was announced last year in October at Microsoft Ignite. And the best way to think about this is Microsoft and its extended partner network has built up an immense amount of experience in understanding what are the core pillars of data management that you need in place to be able to provide insights, to provide data that's ready for insight as well. CluedIn was one of these original 12 partners, and due to this, we have increased our integration into data governance platforms like Microsoft Purview and also some of the other Azure data services you saw earlier in the slide. We're fortunate enough to also be the first MDM solution to integrate with Azure OpenAI, available to everyone on this call to spin up in your own environment with a 7-day trial. We are a recommended reference architecture for MDM in the Azure ecosystem, and the analysts have their own things to say about CluedIn's use of graph, CluedIn's use of zero modeling, CluedIn's use of agility, user experience, and so forth. So Henri, I'm going to hand back to you to talk through some of the obvious FAQs that people are going to have about the use of this, but also the use of, I guess, the common FAQs around privacy and so forth. Henri, you should have the screen back.
Yes, I do. Thanks a lot, Tim. And thanks a lot for the great demos. These were some really good examples of how we can actually use Azure OpenAI in practice. Now, you already mentioned the term FAQs. I just wanted to highlight that because I'm not quite sure if I brought it up in the beginning, but you are, of course, welcome to ask questions. We do have a chat box here, and Tim and I, we will be taking questions in the end of the webinar, which is actually coming up shortly. Yep, Natasha?
Hello, it's the moderator here. Just to let you know, we have actually had quite a few questions. So for those of you that have asked questions, they have all been noted down, and we will keep some time at the end for Henri and Tim to answer them.
Perfect, great. Before we get to the questions though, I just want to spend a few minutes to also talk about using AI responsibly. Because of course, whenever we talk about using AI, this is one of the obvious topics we need to address as well. What you see on this slide here are the responsible AI principles that Microsoft is working with. And our partners like CluedIn, by building on the Azure platform, are adhering to these principles as well. What that means in practice is that your data is your data. When you are using CluedIn and you're using the OpenAI integration in CluedIn, you're not sending your data to OpenAI. You're not sending your data to ChatGPT. You're not training someone else's model with your private data. If you're using your data governance system, or if you're using your MDM, your OpenAI integration in CluedIn to, for example, like how Tim showed, format phone numbers in a particular way, that private data does not leave your Azure subscription. Those phone numbers will not be sent to OpenAI to train ChatGPT or anything like that. The OpenAI service is deployed like any other Azure resource in your own subscription. So you get to decide where it is deployed in terms of data residency. For our EU customers, for example, you have the choice to deploy it in West Europe, which is also covered by the EU data boundary. You have the option to put it, for example, behind virtual networks to ensure that there is security considerations that are being met. And you have, of course, the option to restrict access with role-based access control, just like you're familiar with it from all the other Azure services as well. Now, one thing that is also important to bring up is a particular one of these principles here, and that is accountability. Naturally, someone has to be accountable. We cannot just blame the AI model if something goes wrong. Therefore, it's always important to keep a human in the loop. Like you've seen with CluedIn, we have the option to automatically enrich our data. But we also have the option to say, look, we want to be in control. It's always a good idea to think about how can we make sure that the AI augmented data is not, going rogue, that we as humans still remain in control. So when you're working with AI, think about how can you have humans, for example, approve automated changes? How can you have humans review? How can you have humans provide feedback to potentially roll back unintended changes as well? And what I've heard from Tim, without giving anything away, is that is also something that has definitely been considered in CluedIn as well. I want to close it here for now and just open up for any questions we might have. I've already heard we have a lot of questions, so I'm very much looking forward to answer them together with Tim here.
We do. Thanks, Henri. So first question I have for you. Does Azure OpenAI keep a record of all queries that have previously been sent to it from CluedIn?
Yeah, so Azure OpenAI does not retain any data long term. There is an abuse detection system, but data that you send to Azure OpenAI will not be stored anywhere long term or be accessible in any other way for longer than is necessary just for that abuse detection.
So the answer from the CluedIn side is no, also no. This is one thing that I've also learned from working with Henri, who's kind of dove deep right into it as well, is that these prompts that I put together, they're pretty simplistic, but actually what's happening behind the scene is that CluedIn's using its graph to automatically append extra context into the prompt so it can provide more context. That extra context that we provide, obviously also, there's no persistence in the large language models. There's no cached queries that happen on the CluedIn side that would escape into, outside your tenant, as Henri used the terminology before. So we've done a big focus on privacy and making sure we're also compliant, but most importantly, that data sovereignty piece is covered from both sides.
Great, fantastic. Thank you both. Next question. Does every customer using CluedIn's Azure OpenAI integration get their own instance of the OpenAI model or a shared one?
Why don't you go, Henri?
Yeah, so this actually relates very much to the previous question that we just had. It's very important to understand that like Tim already mentioned, essentially these models don't have any memory. Every single call we make to the models, we provide all of the information that the models need in order to reply. That also means that the models don't retain any customer specific information. So we can use, essentially, of course, the model you're using is deployed specifically in your Azure subscription. So it is, within your tenant and your own model. But of course, it is essentially the same model everybody is using. It's one, base model. It's not necessarily that you are training an individual model that is specific to you and that would answer differently than it would answer to someone else. It's essentially the differentiation is based on the data that we're passing, that CluedIn is adding from its graph when it is creating the prompts. That's right, Tim, right?
It's 100% right. It's exactly the same way that the Office 365 Copilot is working as well.
Exactly.
Is that when you're putting in a prompt, what it's doing is it's looking into Microsoft's graph and it's adding context so that during that, I guess you could call it like a session. There is the idea of kind of like a session where you're providing and building context, but there's no long-term persistence of this at all. It lasts for that particular session. Now, the examples that I showed you before, each prompt was its own session.
Mm-hmm.
So there's no persistence across those different data quality, the rule actions that I put in there. However, including if you chain multiple of those rule actions together, it builds its own session. And in that session is where you can start to at least set context that lasts for all of those rules. For example, you might actually have a default rule on every single, a rule action on every single one of CluedIn's rules that says, keep all of your answers discrete in one word, or for the next set of prompts, return only true or false for every single prompt that you write. And that sets a system context for that session, but the memory of it does not last after that session is finished.
Great, thank you so much. And I think also referring back, Tim, to those brief demos that you gave, the next question is, can you ask the AI the department name and then standardize/normalize against a reference list of departments, which is a curated reference list?
You sure can. And it all comes back to, believe it or not, it's answered in the previous question as well, is that apart from the prompts, you can also, there are ways in building those prompts in CluedIn that you can say, using this list of records and its values, now tell me which department is closest to the reference lookup in the data that you're feeding in, okay? So the challenge is going to be if that reference data is 2 million rows. Obviously, there's limitations on the size of the prompts we can give, but probably maybe even more important, there's cost factors on the amount of tokens that you're asking in these prompts as well. And because of that, that's exactly when you would want to start looking into the ability to append your own reinforcement and bring your data into your own models. Now, this is something that is not available in CluedIn with OpenAI today. This is something we are working very heavily on with Microsoft in regards to, before I ask you these prompts, here is the list of all the companies and vendors that we work with, and provide that as another training set on top of the base models that Henri talked about.
Great, thank you. Next question. We are asking general questions to an ever-transforming and evolving AI. Don't we risk getting a different response next month? Yes, we're asking specific questions, but is this a risk?
Yes, yes, yes. So this is to some degree why the term of a prompt engineer has even come up, because there is nuance in writing these prompts. And although between you and me, it looks like I spent 10 seconds just writing a natural prompt, the fact is that this is an iterative process to get the prompts correct. Here's a really practical example. Imagine a situation where I said, well, I did it before, standardize the phone number, okay? What happens if the input is not a phone number? Well, the AI will provide a response that instead of giving you the phone number, it will give you this response of, sorry, that does not look like a phone number. It looks more like an email address. And that's something you couldn't automate, right? Which brings you back that the key is in your ability to build a prompt that can handle edge cases. In that case, you would add the extra prompt of, and if it doesn't look like a phone number, don't return a result, or just return an empty value, or just return the input that you gave me. And in that way, the AI is not actually going to do anything. It's going to come back and say, this is what you handed me. It was supposed to be a phone number. It was actually an email. I'm just going to pass you back the email because you've catered for that in your prompt. Now, the question also touched on, I guess, the fact that these are moving models, right? This is why it's so important to be able to involve a human in that process. The ways that we do it here at CluedIn, this is automatically done for you, actually. There's no, every time you write a new rule action, and Henri actually just alluded to this before, without you knowing behind the scenes, we're asking another prompt that says, that inputs the prompt that you gave it, but then also asks for a match confidence from the engine between 0 and 100. That match confidence will help us short circuit the process. Anything that's not a high confidence will go into an automated workflow, and then, to Henri's example, it will involve a data steward. It'll ask them, this is what the AI gave, this is the explanation, this is the match confidence, are you fine with applying this transformation? The funny thing is, the AI is giving you that response because it thinks it's 100% confident. So you can't just ask it to provide you with a match confidence between 0 and 100. You have to be very specific on what 0 to 10 means, what 10 to 20 means, what 20 to 30 means. And so there is unpredictability in these, but there are ways to be able to force it into a predictable channel. We should all move forward with the idea of these things will happen, and the way to get around them is to realize that you'll be evolving these prompts over time to deal with these edge cases. And this is exactly what would happen if you had an IT team go off and build these types of standardization libraries. There'll be exceptions, you'll iterate on it. Henri, did you want to add anything on that?
Yeah, I would love to, because I think you brought up a very good point here, and I don't think you meant to make that point, but when you are specifying what it means to be certain, this is exactly what you should in general do when, in order to get more reliable prompts. Also, when you are, like you guys who are attending the webinar are writing your own prompts. If you ask, does the sentence have PII data? Then you are more likely to get a good and a reliable response if you tell the model, what do you consider PII data? Right? Is salary PII data? Maybe you get a yes, maybe you get a no. But if you specify, does this model contain PII data, which I consider this, and this, then you're much more likely to get a reliable response, no matter if the underlying model changes or not.
Right. Excellent.
Thank you, guys. We do have a couple more questions. I'm aware that we're close to time, but I'll try to whiz through as fast as I can. I think we've all already pretty much answered this one. But one of the questions is, within the responsible AI principles, Henri, you mentioned that we always have a human in the loop, but I didn't get how this principle is implemented.
That's a good question. No, I wasn't, or I didn't mean to say that we always have a human in the loop, but I think we should always consider how can humans be accountable for the AI output. In the case of what we're doing here with CluedIn, this is how Tim mentioned that if we get low confidence, we have a human to look over it. often we use these AI technologies for automation, right? And it's just not feasible to have a human in the loop for thousands of small automated tasks. Then there wouldn't be a point in automating it in the first place. But there needs to be something in place to make sure that in risk scenarios, in high risk scenarios, and high risk sometimes could just be low confidence, that we can involve a human. This is what I'm referring to with human in the loop.
Yeah.
Fantastic, thank you. And I think this one is more of a clarification, but so OpenAI is given as a platform as a service that we can deploy on our subscription and fully configure regarding network isolation, etc. This means that CluedIn has a configuration settings to point to this service. Is that correct?
Correct. And you can also, for every rule, you can use different models. So when Henri said before, listen, we might not be talking about images in this. Because CluedIn supports unstructured data, you can pull in PowerPoints, you can pull in Excel, you can pull in Word documents, PDFs, you can pull in images, video, audio. Therefore, every rule might need to use different models. For example, DALL-E, right? Or for example, we might be bringing in PowerPoints. We might want to use a different model that that is good at understanding that version of content. And you deploy these different models through the Azure OpenAI portal. DaVinci is the one that I used for my examples.
Wonderful. A couple of very quick last questions. Do you have a set of standard prompts out of the box?
We have a library you can install. It's available on our documentation portal. It's not installed by default, but we have, as you can imagine, a majority of the same types of standardizations will exist across common domains like customers, employees, companies, and things like this. There is an open source package that you can install that has all these rules in it.
Great. And finally, what build is this included in?
This is in the latest build of CluedIn. We released what we call our Dagobah release. I'm probably going to get sued by LucasArts for that one, and Lucasfilm, sorry. That was released today. The trial that you can go onto the Azure portal today and install is also running on this latest release. So this was officially released today. We have been running it with Lighthouse customers for about the last 2.5 months. We have customers in production with this, which is the most important part. These are not things that are toys that are in sandbox pilot modes. These are being used in production with our customers.
Great, and that wraps things up. Tim and Henri, thank you very much.
You're welcome. Thank you guys for joining us. Thank you.
Absolutely. Thank you.